Hi everybody, I'm Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory. Now, many of you know that Yellowstone deforms, it rises and falls. The ground is incredibly dynamic, and so today I wanted to tell the story of that deformation. How we know about it, what's happening now, what's happened in the past, and what may happen in the future. And that story starts right here in Hayden Valley in Yellowstone National Park. Now in the 1920s, when the road system was laid out, a number of surveying benchmarks were installed, like this one right here at my feet. A number of these benchmarks came in the 1920s, and they were surveyed to tell the elevation along the road to help surveyors build the road. Now in 1975, there was an earthquake near the Norris Geyser Basin, magnitude 6 earthquake, and there was some thought maybe there was some deformation associated with that earthquake. So in the mid-70s, the whole network of benchmark was resurveyed, and the surveyors couldn't believe their eyes. In fact, as the story goes, they thought they'd done something wrong because they found that the elevations were very different than they were in the 1920s. In fact, the ground had risen over 70 centimeters, over a centimeter and a half per year of uplift between that time period, the 1920s and the 1970s. So this was the first evidence that Yellowstone actually did deform, this uplift in the 50 years between the 20s and the 70s. Now the leveling line was redone again in 1983, and guess what? Still deforming. 1984, still deforming. So these surveys were carried out starting in the 80s every year up and down this stretch of Hayden Valley right here. And this became really the epicenter of looking at deformation in Yellowstone National Park. So 83 still uplift, 84 still uplift, but 1985 it was flat, no uplift or subsidence. In my 1986, the ground was subsiding. This was a tremendous discovery, that the ground not only went up, but it also went down. And that subsidence continued into the 1990s, when in the mid-90s, guess what? It started to go up again, almost as if Yellowstone was breathing. So leveling, this technique whereby a survey crew sort of moves along a road and measures elevations, revealed the ups and downs of Yellowstone really for the first time. The challenge with leveling is it requires a lot of people and it requires a lot of time, and you only get the measurements maybe once a year. And so in the late 1990s, some new technology came onto the scene, specifically INSAR, which was a technique that uses satellites to essentially take a picture of deformation from space, and GPS, the global positioning system, the same thing that's in your phone or in your car. And using continuous GPS stations, we're able to see not just vertical deformation, but also horizontal deformation, and get that information in real time, 365 days a year. So to continue the story next, I'd like to take you to a continuous GPS site. So let's go have a look. This is one of a couple of dozen GPS stations that are located in and around Yellowstone National Park. Satellites transmit data. It's recorded by this antenna right here, which is located above the winter snow line and on a very stable base, so that any motion we see is most likely due to ground motion and not some artifact. The GPS receiver itself is in the box behind me, and that's powered by a bank of solar panels and batteries, and the data are transmitted by radio link to processing centers like UNAVCO, which runs GPS stations across the western United States. These data are all available online, so you can download it and see exactly what's happening in terms of Yellowstone deformation for yourself. Now, when these stations were first installed, we had only had leveling before, really. And those leveling data really only gave you information when there were people in the field. At best, you were getting information once a year just from a few places. But there were so many GPS stations that could be installed, and they gave such great temporal resolution, we get a data point a day from these, that we got a much better sense of how Yellowstone was deforming. So after that brief bit of uplift in the mid-1990s detected by leveling, GPS installed in the late 1990s detected subsidence of the caldera until about 2004. From 2004 to 2010, Yellowstone caldera was uplifting. From 2010 to 2014, subsidence. From 14 to 15, 1 year of uplift. And from 2015 to the present, 2020, there was about a small amount of subsidence. And that subsidence and uplift is occurring at rates of 1, 2, 3 centimeters per year. That's about an inch or so a year, and it's about the same rate that we were seeing with the leveling technique. So the deformation is very small in scale. But it's not just the caldera that's deforming. Norris Geyser Basin outside the caldera on the north side deforms as well. This was first discovered in the late 1990s with INSAR, that technique I mentioned earlier that uses satellite imagery, radar imagery, to take a deformation picture of the ground. Now, this picture spans the late 1990s to the early 2000s and shows uplift in the Norris area. These colored fringes indicate uplift. Now, there were no GPS stations in the Norris area at the time, so we wouldn't have known about this deformation without INSAR. Well, when the GPS stations were installed in the early 2000s, we saw subsidence of Norris after that uplift episode, no change from the late 2000s into the early 2010s, and then rapid uplift in 2013. That uplift culminated in March of 2014 with a magnitude 4.8 earthquake. Right after that earthquake, Norris began subsiding. So that was probably water that was backing up beneath the Norris Geyser Basin, behind some sort of valve that was holding things back. And the earthquake was that valve breaking, and the water draining out caused the area to subside. Shortly afterward, in 2015, we started seeing uplift again at Norris, and that lasted into 2018, where it plateaued through much of 2019. We saw subsidence at the end of 2019 and then through into 2020. Not much change at Norris. This is how Yellowstone behaves. It's incredibly dynamic. The ground is constantly moving up and down, and that's the kind of thing we expect to see in the future. At some point, the caldera will begin uplifting again, and Norris will go up and down as well. So we know what's happening from the 1920s into the 80s and 90s thanks to leveling. And we've got great news about deformation, great information thanks to GPS and INSAR from the 1990s up to today. But what was happening before the 1920s? Is there any record of deformation that goes back from before humans were actually making measurements? And it turns out that there is. And for that, we're going to have to make one more stop and look at the geology of Yellowstone Lake. I'm standing here on the northern shore of Yellowstone Lake, where geologic evidence allows us to see how the Yellowstone system has deformed over the last several thousands of years. In fact, since the ice melted about 15,000 years ago and the last ice age ended. The outlet of Yellowstone Lake, the Yellowstone River, flows across the caldera and the area that goes up and down. So whenever the caldera rose, the lake outlet would rise, and that would cause water to back up in the lake. And whenever the caldera subsided, the lake outlet would go down, and that would allow more water to drain. So the lake actually would rise and fall with deformation. And every time it rose and fell, the waves on the lake would cut a terrace, like a bench, into the margin of the lake, into the shore. I'm standing on one of those terraces now, which you can see is actually above the level of Yellowstone Lake now. So where I'm standing represents a period where Yellowstone Lake was higher. And in fact, even above me is yet another terrace that represents a time when Yellowstone Lake was even higher. We can date these terraces based on some of the geologic and even archaeological evidence that's preserved on the surface of the terrace. Not only artifacts, but also ash layers. And some of those ash layers, they're not actually from Yellowstone, they're from the Cascades. So for example, the eruption of Mount Mazama that formed Crater Lake 7.7 thousand years ago, we can see that ash here, and it serves as a marker bed for knowing the ages of these terraces. When you put all of that together, you can see that the level of Yellowstone Lake has risen and fallen over thousands of year timescales. And the deformation that might have caused that rise and fall could have been uplift and subsidence of up to 30 meters. That's about 100 feet over thousands of year timescales. Now, since the ice receded 15,000 or so years ago, the net deformation has been subsidence, which means we're actually lower now. The ground has subsided, the caldera has subsided since the ice melted. But it's happening in cycles. And there have been at least 2 of these large rise and fall cycles in the last 10,000 years or so, based on the evidence of what we see here in the terraces. And what's causing this great big rising and falling? Well, certainly magmatic intrusion could be something that would push the ground up. But given that there's so much subsidence as well, it seems like the hydrothermal system, what's powering the geysers, all the hot water beneath the surface, is playing a role as well. And so the accumulation of these hydrothermal fluids and then they're draining away can also cause the caldera to breathe, essentially, on both thousands of year timescales as well as human timescales, the sort of deformation that we've seen happen just in the last few decades in Yellowstone. Well, thanks very much, and if you have any questions, you can feel free to email us anytime. Our email is yvowebteam@usgs.gov. Take care, and we'll see you next time.